Today we're going to look at dividing exponential expressions. We know how to multiply them, we know how to take a power and raise it to a power, we know about negative exponents. So this is pretty much like the fourth installment of exponential properties, and it's focusing on dividing. So let's take a look at the long method. I like teaching you the long way around doing the math because you can normally remember how to do the long method because it's more intuitive. Then we'll come back through and show you the shortcut, and you might like that better. First off, make all of your exponents positive. So in this first expression, you see that's got a positive 3 for the exponents, and that's fine. If you see down here in the bottom of it, there's no exponents, so we know that's a positive 1 anytime you don't see an exponent. Looking at the exponents in this expression, you know that 9 has an exponent of a positive 1, that 3 has an exponent of a positive 1, this n positive 3, and this n is a positive 1. Same thing down here. They're all positive, so there's nothing we have to do there. Next, I say just go ahead and write it in expanded form. So what b to the third literally means is b times b times b. And b to the first is just, you know, this lonely b that's down on the bottom. After you do that, divide. Well, you divide the top by the bottom. We only have this 1b down here, and that can divide any of these. In fact, let me just kind of drag that over to the left a little bit. Makes it a little bit easier when you see it lined up vertically. b divided by itself is 1. And 1 times b is still b to the second. And that's it. We're done with this first expression. That's how we divide exponents. That's how we divide exponential expressions. So if we come through here and let's put a dividing line here, so that way you know this one's all by itself. What 9n to the third power really means is 9 times 3 different n's. And the same is going on at the bottom, except for it's a 3 times just the 1 n. And so now that we've made sure that we have all positive exponents, we've expanded it, we can go through and divide. Well, what is 9 divided by 3? Well, it's 3. And n divided by n is 1, so it kind of doesn't necessarily go away. In fact, let's do this. N divided by n is 1, so let's just put a 1 right there. And then we've got 2 n's left over. Forgot the multiplication symbol, so let's put that in there. And we know 3 times 1 is 3, and n times n is n to the second. So what I'm saying is that the coefficients, you know, these numbers that are multiplying the variables, you could treat them just like a regular division problem or a fraction, as you'll see down here with this one. The 2/6 will simplify down to 1/3 in just a second. But I don't want you to say that this just magically goes away. Any number divided by itself equals 1. Well, that slides right up on top, and it's going to be multiplying anything else that's left on top. To save yourself a little bit of time, there is nothing wrong with going, okay, 9 divided by 3 is 3. These will equal 1, and then you just don't write the 1 here. Then you go ahead and you say, well, and then we've got n times n left over, and we still get 3 n to the second power, just like we did doing it the long way around. And pretty soon, this part right here, you'll be able to skip it, and you'll just be able to say, well, 3 n to the second. You'll be able to get straight to this final spot. Hopefully, you might even be able to skip this part too. Now, let's go through and finish this last one with this long method, and then we'll come back and show you the shortcut, show you a few more examples, and then get you some practice and check problems. Here we go. 2 times m times m times m times m. Put our fraction bar in. And 6 times m times m times m. Now, 2 divided by 6 is a repeating decimal. Not the easiest thing to deal with usually. So what I would recommend is think of this as just like a fraction. That's 2/6, just like this, 2 over 6, and it simplifies down to 1/3. That's what I would recommend that you do. So let's do that. Let's make that 1/3. This m is going to be divided by that m, and that'll make it 1. M will be divided by this m, that'll make it 1, and m divided by this m will make it 1. And we have 1m left over, and it's on the top part, so we have 1m over 3 or m over 3. Either one of these would be fine. Now, let's take a look at that shortcut. You would divide or simplify your coefficients. So there's no coefficients here, nothing to worry about. Over here, your coefficients, we would divide. 9 divided by 3 is 3. Okay, so that's what we're talking about when we say divide or simplify your coefficients. Here, we would be simplifying them. 2/6 equals 1/3. That's how you handle the coefficients if they're there. Now, the last part that you would do is with your exponents is subtract the exponents of same bases, dividing each other, and keep the same base. So here they have the same base. This b to the third is being divided by b to the first. So just subtract your exponents. What's 3 minus 1? 2. What's your exponents here? This n to the third is being divided by n to the first, so 3 minus 1 is 2. And this one, m to the fourth divided by m to the third, well, 4 minus 3 is 1. And that's the same thing. The shortcut can kind of make it easier when you're dealing with these examples right here. But before we get there, I want to do it the long ways for all 4 of these, and then I'll come back around and we'll do the shortcut as well. So here's the long method. 8 times x times x times x. All positive exponents, we're good to go. 6 times x times x times x times x times x. Now we can just go through, cancel it out, except for it's not really canceling out, it's just making it 1. X divided by x is 1. And so we've got 2 x's left on the bottom. So let's make that x squared. What do we do with our coefficients? Well, 8/6 is more of a fraction, so we'll make it 4/3. And that's our final answer. So, the long method, it works. It's not too difficult to deal with. Let's do a shortcut. Divide or simplify your coefficients. 8 over 6 goes to 4/3. And what's 3 minus 5? Remember, keep, change. It's going to make it -2. Now, after you do this little shortcut, the question is, what do I put it on top or on bottom? Always put it on top when you're doing the shortcut. 3 minus 5, keep the x on top, and this is -2. Whatever your answer is always going to be up on top here. Now that we've done the shortcut of subtracting our exponents, what you need to realize is, I'm still not allowed to finish my final answer with negative exponents. So the 4 and 3, they have their +1 exponents here. So they're happy, they're going to stay, they're positive. But now this negative, just flip them down to the bottom level. And there we go, 4 over 3, x to the second. Okay, let's try this one. First off, long method. Make sure that all of your exponents are positive. We have a huge issue right here with this negative first power. So flip that upstairs to where it's multiplying into the second. So that's how we would make it positive, right? This is a negative exponent, so we just flip it upstairs. And when you flip it upstairs, it's going to multiply anything else that's sitting up there. So into the second times into the first. What does it really mean? Write it out. N times n would be n to the second power, and n to the first is right there. And oh goodness, this is the easiest way to look at it. That'll be n to the third over 9, and we're done. Well, it's the long method. It does take a little bit, but it's not that complicated. Here's the shortcut though. First off, look at your coefficients. I'm only seeing one coefficient, so keep it exactly where it's at. What's 2 minus -1? 2 minus -1. Keep change, change. Ah, that's positive 3. And we always put it on top, so n to the third. There we go. Same thing we just did doing long method. Positive exponents, nothing to change there. So 6 times x times x times x times x over 2 times x. Simplify or divide your coefficients. This would be 3. Divides to 1, divides to 1. X to the second power. 3x to the second power. 3 times x to the second power is the answer there. Let's see if our shortcut makes it any easier. Divide or simplify your coefficients. That'd be a 3. Let's see, both positive exponents here, so that'll make it easier. 4 minus 2 is 2. Answer always goes on top level. Now, here we have this issue. Make your exponents positive. So what we have here is where they were both negative. They're literally just going to flip to different places. And now we've got 7 multiplying itself 6 times. 5, 6. There's the 6th one. Now we got 8 7s down here. And now, let me flip to a different color. We just go divide. We've got 7 to the second power on the bottom. And all we have is a bunch of 1s multiplying each other on top, which makes it 1. 1 over 7 to the second power, or 1/49th. Now, I think this is where you'll really start to appreciate the shortcut more than anything else, because we don't care if it's got positive exponents or not. We're just saying, well, let's divide our coefficients. What's 7 divided by 7? 1, right? And what's, in this case, what is our exponent's base? Well, it's a 7, so we'll have that multiplied by a 7 right here. And negative 8 minus negative 6, keep, change, change. Well, negative 8 plus 6 is negative 2. Now, remember, can't have negative exponents, so 1 over 7 to the second power. And I'm not really happy how I did that with the shortcut there, so let me back it up here. Let's just simplify it. Do you see any coefficients that are just, non-exponential? See this 6, it's got a 1 for an exponent. This 2, 1 for an exponent. We call those coefficients. Here, the 7s are not really the coefficients. They're the base, because they're the same. It's like how it was here in the x and the n and the x. So let's just do this. There's your 7. Negative 8 minus negative 6 is negative 2. This is negative exponent, so move it down below to make it positive. Put a 1 there as a placeholder. There you go. At this point, pause the video, do these 3 problems, see if you get the right answer. I don't mind if you do it long method or shortcut method. Just make sure you can get the right answer. Okay, here we go. Here's the answer number 22. Here's the answer number 23. Please keep in mind that the 7 and 9 cannot be reduced any further. They can't be simplified, so it stays the same. 5 minus negative 3 equals positive 8. That keep, change factor. 24, we'll do this one together. 7, 6, I can't simplify that. That's what we do with our coefficients if we could. If we can't, we just let them sit. What's negative 3 minus negative 3? Well, keep, change. Negative 3 plus 3 is 0. So it's n to the 0 power. Remember, anything to the 0 power is 1. So my final answer is just 7/6.